uno.
Good evening, class. Welcome to Mr. Ramos' lesson, where we will be learning how to do basic stoichiometry. And first, we will start out by balancing the chemical equation I have set before us. Due to time constraints, we will not actually be doing this,
I dare use my lines.
which will give you potassium chlorate will equal 2 KCl plus 3 O2. And it's always important to balance your chemical equation first, otherwise all of your numbers are going to be off and it's going to suck. So, the first question that we have for us today are, when 62 grams of potassium chlorate are reacted, how many moles of KCl will be formed? Well, first, we need to convert from 62 grams of potassium chlorate, and we're going to be wanting to convert this into moles first. So we're going to write our grams of potassium chlorate in the denominator. This will help cancel it out and change it to moles, which we'll put in the numerator. And the molar mass of potassium chlorate can be found by adding up the molar mass of potassium, chlorine, and oxygen. And that's how we get the number here, 122.
You sabotaged me.
Next, we're going to, but this is net, because we need this into moles of KCl, which we will find by doing this part of our equation. We will transfer from moles of potassium chlorate, it's going to get a little bit squished, into moles of KCl, and you get this number. This is called the molar ratio, which we find from the coefficients in our equation. And for every 2 potassium chlorate, there's also 2 KCl, so that works out nicely. And once we do this whole equation, we will get roughly 0.5 moles of KCl, and that's our first answer. Alright, so our next question, class, is how many molecules of O2 are produced from 2.85 grams of KClO3? This question will be a bit trickier, but for stoichiometry, take it one step at a time. So first, we're going to go from grams of KClO3 into moles, using the same step we did last time on our previous problem. Next, after we get this into moles, we're going to want to do the molar ratio, because we're trying to find molecules of oxygen. So we need to convert this to moles of oxygen, which can be done using the molar ratio, which we will get from our equation, from the coefficients of our equation. So this will be 3 moles of O2 over 2 moles of KClO3. Again, it's important to write your units so we can show how they will cancel out throughout our problem. And lastly, because we want to convert this into molecules, we will be multiplying by Avogadro's number, which, as we should all know, is 6.022 times 10 to the 23rd, which I will abbreviate with AVG, over our 1 mole of O2. And once we plug all of this, our big equation, into the scientific calculator, we will get the answer of 2.11 times 10 to the 22nd molecules of O2. And there's our answer for part B. Almost there, guys. Alright, lastly, part C. 3.54 grams of oxygen was produced. How many grams of potassium chlorate were used? Well, again, we want to take this one step at a time. So first, we are going to find the moles, how many moles of oxygen are in 3.54 grams of oxygen. Using the same thing we've been doing, 3.54 grams of O2 times 1 mole of O2. The molar mass of O2 is 16, and since we have two O2s, we want to multiply that by 2, so we get 32 grams of O2. Next step of our equation, we are going to be wanting to get to grams of potassium chlorate. Therefore, we must first convert into moles of potassium chlorate. We will do that using the molar ratio, which we get from the coefficients of our chemical equation that we balanced at the start of this video. O2. And the last step of the equation will be just to convert into grams of potassium chlorate. We know from earlier the molar mass of potassium chlorate is 122 grams KClO3 over 1 mole of KClO3. Once we plug all of this into our calculator, we get the final answer of roughly 9 grams of potassium chlorate. And that's our answer. And that, ladies and gentlemen, is how you do stoichiometry. Have a great day.